NASA has been monitoring this crater, which resembles a happy face, in the south polar region of Mars for over a decade. Images that were taken between 2011 and 2020, at roughly the same season, show color variations that are due to different amounts of bright frost over darker red ground. The blobby features in the polar cap are due to the sun sublimating away the carbon dioxide into these round patterns. 9 years of this thermal erosion have now made the mouth of the face larger. The nose consisted of two circular depressions in 2011, and in 2020, those two depressions have grown larger and merged. Valles Chasma is the widest segment of Valles Marineris, the largest canyon in the solar system. In this region, hydrated sulfate salts have been detected and are found extensively throughout the canyon. A treasure trove of organic molecules have been discovered by the Curiosity Mars rover, including 7 previously unknown. It lends credibility to the argument that early Mars could have supported life. However, organic doesn't mean alive, it means carbon-based. So, technically, geological and meteorological processes could form such molecules without the need for life. But the more diverse the set of organic compounds that can be cataloged, the lower the chance that they could all have formed abiotically. The molecules were discovered using the sample analysis at Mars Mini Laboratory, built into Curiosity's belly. The rover can take a small rock sample and grind it into a powder, which can then be superheated to cause the sample's components to vaporize. The SAM instruments use spectroscopy to analyze these gases. But SAM also has a much more rarefied form of analysis, called wet chemistry, which uses a finite supply of liquid solvents for only the most important samples. Curiosity examined this recent sample by dropping it into a vessel containing tetramethylammonium hydroxide, becoming the first sample deemed vital enough to use in this way. Overall, the analysis revealed an enormous catalog of organic compounds. Back on Earth, NASA scientists also performed tetramethylammonium hydroxide analysis on a sample of the ancient Murchison meteorite, which has been well characterized and contains large organic molecules thought to have been seeded throughout the early solar system. They found that the much larger organic compounds in the Murchison sample broke down in the presence of tetramethylammonium hydroxide, forming many of the same smaller compounds Curiosity observed. This suggests that they could have been generated from the breakdown of such larger molecules, which have long been thought to be relevant to life. In terms of specific compounds, the most exciting was nitrogen heterocycle, a molecule built around a nitrogen-containing ring of carbon atoms that is thought to be a likely precursor to DNA and RNA, and so critical to abiogenesis. Benzothiophene, another new find, is also thought to be one of the critical chemicals seeded through the early solar system. Curiosity is, of course, just one in a line of experiments aimed at surveying the surface of Mars. The European Space Agency will soon operate the Rosalind Franklin Mars rover, which will use a mass spectrometer designed and supplied by NASA to look even more closely at the chemical makeup of samples collected. Valles Chasma is the widest segment of Valles Marineris, the largest canyon in the solar system. In this region, hydrated sulfate salts have been detected and are found extensively throughout the canyon. These salt-bearing deposits likely indicate that water was present in the past. This observation shows many interesting features that are common to Valles Chasma. At the north end, we can see typical ridge and trough features that also mark the rim of the Valles Marineris throughout the canyon system. Emanating from the troughs, we see debris flowing towards the bottom of the slope. The floor of the valley shows sparse exposures of bedrock, which is otherwise covered in dark rippled dunes. Slopes in the north and south reveal layered sulfates that were deposited into the canyon system and subsequently eroded to reveal the layered sulfate-bearing rock. Dust devils on Mars form by the same basic mechanism as ones on Earth. As sun heats the Martian surface, it causes warm air near the ground to rise through the cooler air above and creates an updraft. Horizontal wind then causes rotation, forming a vortex. Thus, the lifting of surface material through the vortex creates a visible dust devil. On average, however, Martian dust devils occur more frequently and are about 3 times as large as those on Earth. The largest vortices can reach heights of more than 8 kilometers and widths of more than 700 meters and last more than 25 minutes. The greater height of Martian dust devils may be due to a planetary boundary layer, which is several kilometers thicker on average than Earth's. Dust devils on Mars usually occur during warmer times of year. Research has revealed highly predictable seasonal behavior, with activity escalating sharply just before Martian vernal equinox, peaking in midsummer and declining after the autumnal equinox. Amazonas planitia, in particular, has been identified as the region most prone to dust devil activity on Mars. Dust devils are believed to play an important role in the climate of Mars. By uplifting large amounts of surface material high above the ground, they may be responsible for as much as 30% of the dust found in the Martian atmosphere, which creates a warming effect and regulates the amount of water vapor in the atmosphere. As they expose lower, darker-colored layers of regolith, the change in surface albedo may alter local climates.